Right, you're recording. Okay, so welcome to the seventh and final session of the V3 presentation, hopefully the final one. So today what we are going to do is go through the exercise of trying to implement the merge primitive for in V3 and kind of see where how far we can go with it. Obviously, the intent is not to implement the whole feature, but I will just go through the motions of what I would do if I had to implement it myself. Unfortunately, I didn't have too much time to prepare, so we may have to improvise as we go. So we'll see how that goes. So the first question we have to ask ourselves is, basically, we first have to study the feature, find out what is allowed and what is not allowed. So obviously, a union is allowed as a high-level query. So that part is simple. And the other thing we know is that the union construct, let me actually open up the editor. If you look at the AST, so union allows union distinct, union, and union all. Union distinct is a synonym for union. So basically, in MySQL, MySQL allows union and union all and nothing else. And so we also have to look at what the difference is between these two. I believe we talked about this in one of our sessions. So basically, union all is a very efficient function because it doesn't have to merge duplicate rows. So a lot of people actually tend to use union without thinking too much about it and without realizing it costs. But you always have to look at whether a union all would have worked, would have been sufficient. Because if a union all is sufficient, you should always use that over union. And union should be used only when you actually require duplicates to be removed by the database engine. So for us, what that means is that if we see a union, because we don't have the ability to aggregate, to sort and aggregate, we can probably only do a pass-through, which means that if the union can be passed through to a single route, then we can do that. Otherwise, we basically have to say, sorry, we can't serve this query yet. Whereas with union all, we can look at actually doing the left and right queries separately and then merging the results as they come and sending them back to the client. So far, so good. The other question we have to ask ourselves is, does a union or a union all have to be a top-level query, or can it be in other parts of the system? Like, can it be, for example, can it participate in a join as a subquery, right? Can you do select join A union B? You can probably do a union of joins, but can you do can you apply a union to a join? My guess is probably not. So these are things that we have to actually study, which I actually didn't have time to study, but these are questions that we have to answer to before we get. So let's assume that for now it is not allowed. The reason why that's a reasonable assumption is because usually people don't write such crazy queries. Being the worst case is, so usually a union is always a high-level query. So a union is never a subquery. And I have a feeling, I vaguely remember reading that MySQL doesn't allow unions as subquery. So which actually simplifies things for us greatly if we say that unions should not be allowed in subqueries, because as soon as you allow subqueries, you have to then worry, okay, if the subquery is allowed, is correlation allowed, right? Because then a union select within a union, is it allowed to reference a variable from the outer query, right? So those are some of the questions that pop up. that greatly muddy up the waters. So I think for this reason, MySQL also doesn't support unions in subqueries because it becomes super complicated and more likely not a practical usage. There's probably no practical usage to use case to do unions inside subqueries. So for us, what does that mean? So let's say that we are, for now at least, I'm going to go through the motions of implementing union and allowing it only as outer query. So that immediately changes one thing, is that if we encounter a subquery and that subquery is a union, we can reject it right away, and we don't have to go inside and analyze it and figure out how to gather metadata about it that can be used in the outer query. But even if it was allowed, I don't think our job is as complicated as that of an engine. Yes?
I actually do think it's allowed in subquery, not as like join A union B, but definitely in like a subquery. I've seen it at least.
Oh, you've seen it? Actually, let me see if we can Google it very quickly.
Together as a subquery and then select from that.
Apparently, this is not allowed. So my guess is that it's not allowed. But yeah, even if it was allowed, I can show you how we can accommodate it. So we can.
Okay.
We can. I think we will reach. That question will come up when we change the code. So we should be able to accommodate it. So let's for now let's keep that open, and then we can, as we go, we can resolve this issue.
Sounds good.
So there are some parts of the code that I did not cover last time. The reason is because those are fairly easy. One is the engine code, right? I didn't show how things are implemented in the engine, or did I show that? I don't think I did. So that is one area. I've also didn't show you the symbol table code, which actually is fairly easy to read. And I did not show you too much of the wire up code. There is actually some confusing section in the wire up code, especially related to column references. So if you try to read that and run into issues, you may have to ping me. There is the basic idea is that there is a data type called a column reference, and that could either be a reference to a table column or a select list column. The way you identify a table column is by the pointer to the table and the column name, because that is what uniquely identifies a column reference for a table. And the reason why you need the column name is because in the symbol table, we only have table references. There is no column name in those tables. So there is no physical column identified to point at from a table. But in a call sim, the pointer itself is sufficient, or the name itself is sufficient to uniquely identify a column, because there are no qualifiers. So it's just keep that in mind when you go through the code. I have a feeling we may not have to wrestle with those things for unions. We'll see. So the first thing we are going to look at is if you go to the engine subdirectory under VTGate, you will see that there is a join.go, which implements the join primitive, route.go, which implements the route primitive. I actually don't know what routing map is. We can look at it later. And there's primitive.go, which actually defines the interface, the various interfaces for every primitive. So the first thing we have to do is look at what is in primitive. So in primitive, you can see that there is a plan, which basically the plan is actually what contains all the instructions. The V cursor is actually our gateway back to VTGate. We call into VTGate when it calls my primitive, gives me a V cursor that I can use to execute queries back with VTGate. And down here is the primitive opcode, the primitive interface, which means that anybody that implements a primitive has to implement these three functions. If these three functions exist, then VTGate can use you as a valid primitive to perform its operations, which is basically execute, which is a normal execute, stream execute, which is stream the results as they come, and the get fields query is in situations where it will call you just to get the fields of, which means that basically it's used only in the case of a join. Like I mentioned before, if the left-hand side didn't yield any rows, it's used to build the right-hand side field information. And if you look at join, the join.go in engines, the reason why I'm opening join is because it's kind of similar to a union all, right? So if we are going to implement union all, then we probably have to do something like what join does, except that we'll implement these functions to do different things. So what I'm going to do is copy join.go to merge.go. So why do I call it merge is because, oh, I guess I closed that window, is because if you went to our design document, V3 high-level design, there are opcodes defined here. So the opcodes that are defined here, if you looked at the description for merge, it says you merge two results into one, basically union all, right? So this is basically the name of my opcode. So I'm going to name my primitive based on this information. So I copied join.go to merge.go, and now I'm going to open it. So I guess I can get it up this file, merge. All right, let's see what we can change here. Obviously, merge doesn't have an opcode. A join needs an opcode because it needs left versus right join. So, oops. So there's no need for an opcode. Left and right are the left and right primitives of the merge, I guess. We'll do the rename. It can be any primitive, that is still true. A merge does not need to tell you what columns it returns because it will not participate in any stitch-up operations. Deleted. There is no need to pass variables from the left to right, so this is deleted. And for now, we will punt on the implementation. We'll come back to it later. So basically, we'll say panic unimplemented. So I'm going to do this. All right, so it's just done. And these things are not needed. These are opcode related stuff. All right, so this is basically my engine. The reason why I'm building this is so that I can go focus on building the plan builder. And so I'm going to save this away. Let's see if it builds. Oh, join, oh, I need to rename. %, merge. All right. Built. Okay. So now we are going to move to the plan builder, where I'm going to build the merge builder primitive. For that, I'm going to copy join to merge.go, and get rid of this, merge. All right, so here, let's rename join to, let's do a whole word. I think this is the syntax, /merge. I'm sure I renamed unnecessary stuff, but we can cross the bridge when we get there. All right, so merge is used to build a merge primitive. It's used to, so let's forget the comments. But we can read the comments to see what it was used for. It's obviously there's no left merge operation. Left and right order are, will they be needed? The left and right order are needed for stitch up operations, and we don't need those, right? Or let's keep it, since you said that it could be in a subquery. Let's keep it here for now. We can always delete it later. There is merge definitely has a left and right. Does merge have a symbol table? If a merge has to be in a subquery, then it needs to produce a symbol table. So let's keep that. Does merge need call sims? What are call sims used for? To answer that question, let's look at our interface that the builder interface. So this is basically what we are doing is building a new type called merge that satisfies this interface. So this interface needs to be able to give you the sim tab. It should be able to set sim tab. See, for example, it'll work only if I can supply an order for it, or you should be able to set the order. It needs to supply the engines primitive after everything has been built. It needs to tell you what is the leftmost route. Set RHS is for left join. Push select is for pushing selects. This operation we should not allow if it's a. Do you think we will ever allow a push select? I don't think you can allow push select in a union. The reason is because of the order in which we parse. A union is always the last operation, the last opcode or last construct that we look at. So which means that you cannot push a select because you do from clause, where clause, select list having, and then at the end you do union. And the only thing beyond that that you can do is actually make that thing into a subquery, right? The union then becomes a subquery. And at that point, it becomes a logical table. And then, which means that you have to then select from that union as far as I can tell. So which means that you should not have to ever push a select into a union or order by for that matter. Basically, you should not be allowed to push anything into a union as far as I can tell. And in terms of wire up, if at all, a wire up, since actually a union merges two completely independent results, right? There is if we have to, I guess if we have to support, if you have to allow correlation, let's say a union can be inside a subquery, and which means that that union can correlate with the outer query, then the wire up phase is still needed, right? Because then every inner symbol has to know its external references, and then when the wire up happens, it has to go fetch the results, in which case we have to support it. Supply and supply var and supply column then will also be needed in the case of a subquery. So for the sake of simplicity, I'm going to, so basically what these functions do will determine whether we will support unions in subqueries or not. If we basically say that unions are not allowed in subquery, then these are all nil operations. Basically, order by null, push miss, wire up should not be allowed, supply var should not be allowed, supply call should not be allowed. But if we are going to allow them in subqueries, then we have to support all these things. So that's basically the trade-off in terms of complexity. So today, let's assume that we are going to only allow top-level unions, which is the most common case. So if we are going to allow top-level unions, I don't think there is a need for left order or right order. I don't think there is. The only thing we should need is the symbol table. Do we even need a symbol table? I don't think we even need a symbol table because once the union is done, the plan is built, right? Since it's the last construct that we are going to look at, I don't think you need a symbol table, but let's keep it in case. And I don't think we need this. Oh, eJoin. eJoin should be called emerge. Emerge. Okay. So this is the engine's merge. I think this should be capital N. Okay. All right. So new join is obviously not new join. It's a new merge. Oh, I think that we'll come back to that. Let's close this side so we have a full window. All right, so now we have the left the merge builder ready. New merge builds a new merge builder, and what does it do? Let's see. So when you build a new merge, there's you need the left and right hand side builder done. There is no join involved in this. And this comment is not valid anymore. So we are not going to, so this is the reason why I thought we don't need a symbol table, is because the left-hand side of the union is its own query, and the right-hand side of the union is its own query. And there is nothing that they need to share with each other. And since this is the last phase of your analysis, the only operation that happens after a merge is actually generate the opcode, right? Generate the opcode and then be done. So yes, I think we don't need a symbol table. Let's not delete the item, but I think we can get rid of the symbol table match. The whole symbol table, no need to set the order, no need to set the opcode. No need. All we do is build the merge. This should be called MB or something, or merge builder, MB for merge builder. But I'm not going to bother. No left order, no right order. We need left and right. There is no symbol table. We need to build the merge, the engine merge, which only has LHS and RHS primitives. Nothing with respect to joins, no opcodes. Return. There you go. So
if we were to want to support the passing through of the distinct, not necessarily support it in VTGate, would we add a merge similar to how there was an a join there, just so that we could pass in whether there was in the AST there was the distinct, or would we not need that at all?
Okay, actually that's a good question. I should have done that first in the first place. Let's go to builder. Let's change gears. Let's go to builder. Okay. So in builder, the first thing we have to do is our game plan here, right? Which is right now unions, we return an unsupported construct. So first thing we do is allow unions and delete it from here. And here what we have to do is build a union plan, right? Oops. So basically what we are saying is that if we see a union, go analyze that union and see what we can build with it. right? And let's open a file called go/vt/plan builder. Oh, VTGate. Union.go. And let's copy a select, I guess. Okay, so we'll call this build union plan. And union, right? And let's look at what select has. So build select plan, let's copy this into that thing. You can always modify it. Okay, so in union, our plan is as follows. What we want to do is analyze the left-hand side of the union, find out what its plan is, analyze the right-hand side of the union, find out what the plan is. And if those two plans are mergeable, then we push it down. We don't care what the operator is. But if the left and right plan are not mergeable, then we see what we can do with that union, whether we can actually do the left separately, do the right separately, and then merge them together. And in that case, what we require is that the union operator be union all, because if it is not union all, then we cannot merge left and right separately. So what that means is that if the left and right are mergeable and we can push it down, then we push whatever opcode we got straight into the route. We don't care what opcode it is, right? But when we decide to do the union ourselves at the VTGate level, then for now we support only union all, which means that do the left, do the right, return the results. But if it was a union and we say that we need to support that also as an opcode in VTGate, then we would have to create a new primitive called aggregate or merge union, right? Union merge operator, which actually gets results from left as well as right, and then dedupes them, and then returns the results. So basically, there is no pushing down of, once we decide to do the union ourselves, there is no chance for us to push down anything about the union to any of the primitives on the left and right. The only thing we could do is basically we could push an order by clause, order by all columns on both sides. And then what we could do is do a merge sort, a merge sort, which would be relatively efficient compared to us doing it ourselves. So we could build a merge operator or a merge sort operator this time. And instead of pushing down just the selects, we actually add an order by clause that puts all the columns in there, right? And then then we know that they are ordered, which means that we can do a merge sort when it comes. So does that answer your question?
Yeah, but I guess it would be even simpler for the case where it was unsharded.
Yes, if it is unsharded, then they have the same route. Then you just push it down. Then there's no. It's a lot simpler. So I'm going to show you that code here. Let's do that first. So we don't need to do any wire up here because each of these is its own plan. Let's see. So no bind vars because we are not going to do any wire up. And this is a union, which means that we have to do a left versus right. So I'll do a left builder process select of union.left. And I need to build a right builder. I'm watching time, make sure that I can cover all the important parts. Okay, so I built the left and right, and we need to do the wire up still, because every subquery within the union can itself be a join or anything complicated, which means that we need to wire up the left hand side and right hand side. But if we are not going to do subquery, we can actually do the wire up immediately afterwards. So we could do wire up or later, it doesn't matter. L builder and wire up or builder. And I guess we need the join table for each. So we need to build a separate join table for each of these things because they are independent. So that you can add it. So I don't want to bore you with my typing. And then finally, the more important question is, I'm going to search for that function because I know I've written that function. Subquery can merge. Okay. So let's. So the question that we have to ask ourselves: we have analyzed the left and right? Now we have to see if they are part of the same route. Because if they're part of the same route, then we don't have to do anything fancy. We just have to push it down. So the way we do that is, if you look at subquery can merge, it actually, the analysis it performs is actually exactly what we need to determine if two unions can merge, right? For it to merge, the left hand side, the left and right have to be routes. The key spaces have to match. They both have to be single routes. And a single route means that you cannot do any scatter. If the opcode is unsharded, then yes, they can merge because their key spaces match and it's an unsharded key space. In this case, it returns nil. Probably otherwise it returns why it can't merge. And then, but if they are sharded, if they are both sharded, then it makes sure that they are both unique opcodes and that their values match, right? If these conditions are met, these conditions apply both for subquery as well as a union. So what I'm going to do is I'm going to write a function, union can merge. The reason why I need to write this separately is because in this case, we have builders and not routes, right? So we currently have builder. I can actually have it return an error. Would an error work? Yeah, it could work. So we'll see. We'll make it return an error, and I will say L route, comma okay, colon equal to L builder left dot. I'll do a type assertion of route. So I'm checking if the left hand side is a route, right? So if it is not okay, if it is not a route, which means that it's a complex join, then I say return can't merge. It has to be a better error, and then I do the same thing for the right. So if I'm at this point, then they are both routes. Then all I have to do is return subquery can merge. Can merge of left comma right. Done. So if this is, I think this is all you wanted, right? So your job is done. You can go home. So here you can say ERR colon equal to, oh, there's already an error, equal to union can merge of L builder comma R builder. If ERR is equal to nil, I guess I could, so we need to do the build to do combine. Actually, we could just combine L and R into a single route, right? This we have to do. And return value. This makes sense so far?
Yep, makes sense.
Then, so basically we don't do this. So if we are here, we have to check if it's a union all. So if union dot opcode, it's operator, I believe, equal to SQL parser dot union Ulster. Actually, I'll say not equal to. Return errors new can't support unsupported. Right? So now we are here. We know that we support union all by doing two left and right routes, right? So this is where I would say return new merge of L builder or builder dot. I guess I can't do. I have to check the error still. Builder, comma ERR. New merge of L builder R builder. If ERR, return ERR, nil, I guess ERR. Oops. Just forget the typos. Otherwise, return builder.primitive. Come on, nil. There you go. So far, so good?
Yep, that makes sense. The one question I have is that so far it seems like we're enforcing through the use of subquery can merge that it's an unsharded single route query, correct? So it's definitely going to one MySQL database.
Yeah.
And so in that case, we could actually support union distinct, for instance, because we don't actually have to.
Actually, all unions are supported. So this code will allow. So basically, what this code is saying is that you build the left route, you build the right route. You haven't even looked at the opcode, whether it's a union distinct or whatever, right?
Yep.
So you haven't even looked at the opcode yet. All you've done is analyze the left, analyze the right, and then see if the left and right can merge. If the left and right can merge, we don't look at the opcode. We say, oh, it's done.
Oh, I forgot about that part. Okay. Yep.
Yeah. So this is the to do, right? At this point, we return and we are done.
Yep. Okay. I forgot that part.
Yeah. So the only time we go past this is it's not the same route, so we have to do the union ourselves.
Yep.
Then we build this. And what does it mean is as soon as we implement this function, our job is done, which is actually what I was implementing there, right? So that is new merge. So this function returns a merge object that has the left and right. Now all I have to do is make sure that this merge object satisfies the builder interface. And once that is done, then my job is done. Then this opcode will freely mix with all other opcodes that are present, which means that you can do all the combinations that are allowed. But obviously, because of the fact that I'm supporting this only as the outermost operator, some of these functions I'm going to say not allowed. But if these other functions allowed, actually had valid implementations, then you can actually have the union be part of be in any part of the query, even subqueries. So that's the only difference. So so I've done new merge. Symtab, obviously, I panic. You should never have to return a symtab. Nope. Set symtab is also panic, right? Because you don't build symtabs. Order, nope. No ordering. What else? Set order, no set ordering. So all these will have to, you will actually have to implement in case if you want to make it, if you want to support it. So we should first study that. Primitive, yes, we need, and I return the emerge. Leftmost, do you even care? No, you don't need the leftmost. Oh my God, I didn't expect this to go this fast. No set RHS. Set RHS is needed only for joins. Push select not allowed. Push order by null not allowed. Push miss not allowed. Yeah, man, I think I should have I should have chosen a harder feature to implement. So you could implement wire up, right? So you could say, let's do the wire up, and wire up will do the left-hand side wire up, but left-hand side wire up should not depend on the right, and right not on the left, which means that I should pass in jb dot right as a root node, and here jb dot left as a root node, because they should not know about each other. Left and right should not know about each other. Supply is not needed. Oh, sorry, I cannot delete it because it will be an error. There's actually a, let me see if I can do YID, DID. No. I think it's YDI. No. There's supposed to be a magic command to delete just the body of the function, which I obviously, there's a panic already here. Whew, that's it, done. Your feature is done. Oh, you still have to, there are places where I've added to-dos, so those you still have to implement. But this is pretty much all you have to do. These things will have more meat if you have to support them in subqueries. And if that is the case, you have to think about what symbols are visible, what type of wire up we should allow. Otherwise, this is all there is to building the merge. Right, so I think we have completed the full story. There are to-dos where needed, and there's probably a little bit more polish that you could use. So does this? So if with just this code and plus implementing the engine code, what we will support is all single shard unions will be supported, and if it's a union all operations will be supported. So basically, if you have a union all, then the left and right can be anything, and they will always work, as long as the left and right can have plans built for each of those independently. So if the left could be a very complex join, the right could be a very complex join, it doesn't matter. As long as it will work, then everything will work. And if we later in the future support merge sort, then we can actually apply that function, that opcode can be applied here to also implement, to also make union work, even if it is not a single shard query. The one thing I could show you is scattercon. the reason why I want to show you is to show how to merge two results. Scattercon is actually a V3, it's actually a VTGate implementation, which basically sends a query to multiple shards and merge the results together. It uses actually a closure. It calls a function and passes in a function as parameter. So that function, what it does is goes to each shard and executes. So basically, goes to each shard, execute the function, and then merge the results together as they come. So this is so you can use this function as your inspiration. But merging two unions is actually pretty straightforward. The more important, the only thing you have to do is you have to do it in concurrently. So you have to fire up both sides of the query and then typically use a channel to merge the results together, which you can get the example for from Scattercon under VTGate. Cool. And so I guess your homework would be, before starting the feature, is to check if union is supported in subqueries. If so, then you have a little bit more code to write than what I have written in terms of the builder implementation. Any questions?
Yeah, this all sounds cool. Thank you very much. If the subqueries, sorry, if unions were supported in subqueries, and we, let's say, only wanted to do it for the single shard initially, would we have to do much of the implementing of those various primitive?
If you want to support it as a single shard query, then I have already written the code for you. You don't have to do anything beyond what I showed you.
Even if it's in a subquery?
Yeah, you don't care, right? I guess. If it is so basically you want to support it as a subquery, but as a single shard, right?
Yeah.
Yeah. Then what you do is, like in process select, there's process select. If you go to so the question is a subquery inside a from clause or a where clause, or a general select expression, right? So if you okay, I know where to take you. Find route. So basically, if you want to support it as subquery, in find route you have SQL parser.subquery, right? So here you would add a new case. Oops. Case right, and you would call here. Actually, then you would have to build something that is similar to process select, which is process union, just like the process select, and actually then do exactly what I did after the subquery, right? So the process union would return a subplan, and then you make sure and you check if the subplan is a route, and if it's a route, then you basically add it to all the subroutes just like you did, and then here, as you can see, the subquery can merge will answer your question. So it should only be like 10 lines of code.
Cool.
And if you look at union, if you look at let me show you select, right? Oops. Oh, we are in select. So in select, the build select plan does the bind wars and does a process select, right? And process select is the recursive call that I call here. So that happens before the wire up. So you'll have to build the union plan similarly, which means that you do the bind wars, then you have to do the wire up at the end, and then you will do a process union that produces a builder, a combined builder. And if that builder is a route, then it will automatically wire up into the find route function. And you could actually, I would say, you may actually be able to reuse code here by saying if it's a subquery or a union, right? You could do this. You could either make the upgrade this select function to take in a union or a select statement, or you could special case the two here and then use the rest of the code below after the plan is returned. Basically, this line onwards, all the way to the end, it's the same code. You don't have to, or I would say just cut and paste it. But I would be, you should check with your app to see if unions are inside subqueries. I would be very surprised if they were. And I will also, because I remember reading clearly somewhere that unions are not supported in subqueries. So, but there might have been some context around that I don't remember. So we can get that checked. So most likely you won't have to even do this. The code that I wrote for union should be basically, where did we write that? I did write it, right?
Was it merged?
Oh, yeah, union.go. Okay, because I haven't saved it yet. Okay. Oh. So basically this part minus, so up to this point, if you're basically up to line 23, if you wrote it, then then support for unions for unsharded queries is done. And it goes one step further, which is it'll also work for sharded queries as long as they are single shard.
Awesome.
And if you go beyond into this, and if you look at merge.go, right? Then actually it's very few lines to actually support a full merge. It's what, 100 lines. You can actually support a top level merge inside VTGate. It's 100 lines of plan building and probably another 100 lines of engine code. So about 200 to 300 lines you can support union all as an operator that VTGate can perform at its level.
Cool. Yeah, we'll definitely try to do as much as we can, and maybe if subqueries, if they work in subqueries, maybe that's the one that we'll just do for single shard.
Yeah. Because if subqueries are allowed, then you should do the find route. You should implement it in find route, because that will still give you a bigger bang for the buck.
Great. Awesome.
Cool. All right. So this concludes our V3 presentation. It took us only 7 hours compared to 10 hours that it took last time.
Good improvement.
All right. So good luck.
Thank you. Thank you very much.